3.2, solving systems of inequalities by graphing. So we went through how to graph an inequality last chapter, right? So you have an inequality. If it's an or equal to, the line under, it's solid. If it's just a greater than less than, it's going to be dashed. And then once you graph the line, you decide which half to shade based on a point you choose. You plug in, and if it's true, you know the side with the point you chose is shaded. And if it's not true, it's the other half that's going to be shaded. Now, as interesting as that is, what actually is useful is if you have a system of inequalities, meaning more than one, the solution is going to be where they overlap. So, how do you actually solve systems of equations? By graphing. First, graph each inequality line, then shade the regions for each inequality, and then the solution is where they overlap or intersect. So, for this first one, I'm going to go ahead, I'm going to graph y is less than or equal to 3. What is wrong with this? Okay. So y is less than or equal to 3. What would this line look like? Can we show with our arms? What will it look like? Do we know? Y is less than or equal to 3. Okay, so what would y equals 3 look like? Y equals 3. So it has a constant y value of 3, right? Constant y value of 3. So it's a horizontal line. So what about here? This is y equals 3. Here's y equals 3, y equals 3, y equals 3, y equals 3, y equals 3. And did we say it should be a solid or a dotted line? Solid. Solid. It's going to be a solid line. Okay, so first we graph the inequality. We knew it's solid because it's or equal to. Now I have to choose a point to plug in and see which half I should shade. Should I shade above the line or below the line? Carly, you want to give me a point? Any point, as long as it's not on the line I just drew. Any point. 2 what? 2 comma 2. All right, so 2 comma 2 is right. Let's see, 2 comma 2 is about right here. So you see the point I chose? If I plug it in and it's true, I know I'm going to shade the bottom, below. If it's not true, I know I'll shade above. So I'm going to plug it in. Let's see, the y value is 2. Is 2 less than or equal to 3? Is that true? Yeah, that's true. So that means I'm going to shade below. Okay, this is exactly what we learned in section 2.6. So I shade. The difference between this and 2.6 is now we have 2 inequalities. I must go back and do my second inequality. Okay, so I have y is greater than 2x plus 1. So I want you to think in your brain without saying out loud, how would you graph this? Will the line be solid or dashed? And how would you go about graphing this? I don't want to make a T-chart. What's the simplest way of graphing? Okay, now that you've thought about it, turn to the partner next to you and see what they think. Do they agree? So Jordan, you can turn around. So you are discussing with the person next to you. How would you graph this next one? Where does it start? How do you make it graph without T-chart? Yep. Just turn. Talk to Don. Just find someone next to you. Okay, do I volunteer? Who wants to tell me how to do this? A D. Okay, what do I do?
Okay, so you go to 1 because that's your y-intercept.
0, 1. Okay.
And then you go up to over to the right 1.
Exactly. Slope. Up to over 1. Rise over run. This is what I mean when I say you don't need a calculator for the graphing portion. We have worked with y equals mx plus b. Slope-intercept form. Here is the y-intercept at 1. So you go make a point at 0, 1. The slope is 2. So up 2 over 1. Up 2 over 1. This does not require a calculator. I want you to think with your brain and be able to connect y equals mx plus b, the slope-intercept form, and a graph. Okay, let's go back to a D. It's going to be solid or dashed? Dashed. Awesome. So it's going to be dashed. That looks roughly dashed. Okay, now that I have drawn my line, I need to see which half should I shade, above or below. Jesse, pick a point. Any point for me, as long as it's not on the line we just drew.
Negative 1, 1.
Negative 1, 1. So right here. Do you see the x? All right, it's just, do you see the x? Okay, it's not on the line I drew, but it's going to tell me, do I shade like above and to the left of the line or below and like to the right of the line? That will help me decide. So you said negative 1, 1. All right, this is the x I'll plug in. This is the y. And I'm going to plug it into my inequality. So it's 1 greater than 2 times negative 1 plus 1. Let's simplify it out. Negative 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Is 1 greater than negative 1? Is that true? Yep, that's true. Since it's true, I will go ahead and I will shade the half where my point I chose is. So the difference between this section and 2.6, where we learned how to graph inequalities, is this has 2 inequalities. The solution will be where our shading overlaps. So here on my screen, you can see like, oh, there's pink, there's blue, and then there's this purplish where they overlap. So the solution is literally going to be this section right here where they overlap.
You have to clarify that that's a solution.
So on your paper, everything, the overlap should be much darker. So there's a couple different things you could do. So let me show you with my different colors. Can you guys see the green?
Yeah.
So I can make lines go this way. Then I could pick a different color and have lines go this way. And then I see where they overlap and you just shade it darker. You could shade it really, really light when you're drawing the inequality. And then when you're done, wherever they overlap, shade it darker. Make it clear to me that you understand when you have a system of inequalities, it's where they are overlapping. So I make it abundantly clear where the solution is.
You use like a highlighter on the top.
Sure, just make sure you're correct because you can't undo it. But okay. How do we feel about this so far? Okay. So I'm going to show you guys how you would graph these inequalities. Okay, so have your calculator, make sure it's turned on, open up the graphs. It's gonna be a point, but sure. So we need to make sure we bring our calculators every day to class. Do you have one?
Yeah, I left my calculator here.
Oh, will you give this to her? Since you're going back? Oh, well, here she is. Alright, so we all should have a calculator. Have it turned on, have it out. So I'm going to go to graphs, and I need to graph my inequalities. So the first thing I see is I don't need an equal sign. What I need to have is an inequality. So do you see where I am with the blinking? You can either push delete, and then it pops up one of the inequalities. So the first inequality, what? Y is less than equal to? Okay. Y is less than equal to 3. If I push enter, it graphs it.
Are you just doing the one we just did?
Yes, we're doing the one we just did just to show you how to do it on a calculator. If yours is in press to test mode, it won't allow you to do it. Question?
Yeah, casting out. Well, I don't know how to get it.
Okay. So if yours is in relation, what's it in?
Right.
Huh? So if you push tab, then you have your So if it's not shown,
Yeah.
are you in press to test mode?
She hit.
You're in press to test mode, and it won't allow you to do inequalities. What's the because it's the school calculator, not your calculator. Let me see if all of these are in there. Yep. This one's fine. You go, sir? Alright, do you have yours? Okay, so on the count of 3, we're going to hold it up so I can see all the screens to make sure we have them all. All right, let's see. Do we know how to do it? Did you graph the other one first?
Oh, I just put in a random one.
Okay, we're doing the example we just did. Can I see your guys' calculators? Did you do it? Okay. All right, so I'm going to show you. Let's do this. Okay, so if you're not in relation mode, that's totally fine. I'm going to try and show the calculator. Okay, so if you go to menu, graph entry, edit, you can click on relation. So notice relation has the shading for inequalities. So you click on relation, that's the second way of doing it. Now our first one was y is greater than or equal to 3, so I'm going to show you now how do I actually put the inequality sign. So you put control equal, do you see where I put control equal? And it pops up the inequalities. Control equal pops up the inequalities, and they have to be in relation mode. So y is less than or equal to 3, so I need to have it be this one, 3, and then you scroll down, and now I can do my second inequality. Y is done. What's the second one? Y is greater than? Greater than 2x plus 1? Okay. So this is what it should look like, and it shows you. Huh? Yeah, good. That's exactly what it should be. Y is greater than 2x plus 1? Oh, wait, is it? Did I do it wrong? Is this supposed to be greater than, right? Okay, this is where it overlaps. So it's a nice thing, your calculator will double check for you. Hey. So your calculator can find the intersection of 2 lines, double check for you. You can graph the inequalities. I've been disabling the inequality graphing so far.
So on our test,
I won't disable it because that's on the no calculator portion.
Oh,
What? Yeah.
We spend so much money on these calculators.
We use the calculators all the time. Yeah.
We want them on the test.
I allow you to have them on the test. Did you know Algebra 2 has a no calculator and calculator portion on every test? And right now in my pre-calculus class, the first 2 tests have been no calculator total. So I allow you to use your calculator for the majority of the tests and quizzes. That is a big difference. All right, let's keep going.
Wait, Mr. Brown, it said I have a syntax error.
Yep. Okay, I will come and look.
Wait, what am I going to do?
Let's see. Okay, because we need to change it into, let's see, nope, not less than. You want it to be greater than? Mm-hmm. Yeah. So, did you see how I changed this into a y? So, 2x. Cool. All right, let's keep going. So the reason I'm having a calculator, no calculator portion is even though I specifically told you guys to show your work when you use a calculator, too many times people just copy straight off the calculator and don't show work, and you can't get credit. So by showing you this way, you know you can't depend on it. It's not going to do the work for you, and it's going to really actually test, do you know how to do it? All right, so let's solve each system of inequalities by graphing. So what would y is less than 4 look like? What does the equation y equals 4 look like?
Wait, do I do this on the?
Nope, we're saying verbally what will it look like? It's a horizontal, and it's going to be dashed. Am I going to shade above or below? Below. If I plug in a point like 0, 0, is 0 less than 4? It is. So I'm going to shade below.
How do you know it's below? Because y is less than?
I plugged in a point. Yeah, y is less than. Also, I chose a point 0, 0, plugged it in. And since the point I chose is correct, it's true statement, I know that that half where it is located will be shaded. All right, let's try next one. So we know y equals a number is a flat line. What about y equals x? What's that look like?
This.
It's a diagonal. Literally y equals x. It's a diagonal. Cool. So by showing you how to do that when you were working on your homework. You guys can like double check your answers. That's great. So I taught you how to do the calculator. All right, y is greater than x. So let's go and let's graph it. So y-intercept of 0, slope of 1. This is y equals 1x plus 0. This would be y equals mx plus b format. Slope of 1, y-intercept of 0. It's just a graph y equals x. Is this going to be dotted or dashed?
Yeah.
Dashed. Oops, sorry. I meant solid or dotted. I do this all the time. All right, and then how do I know whether to shade above or below Cooper? What do you think? Yep, pick a coordinate for me.
1, -1.
1, -1. So right there. So I'm going to plug in 1, -1. So my y is -1, my x is 1. Is -1 greater than 1? No. So I know that that side, where it is located, will not be shaded. I'll have to shade the other side. All right. And then the solution. The solution is where they overlap. It's this triangle portion right here. This is my solution. The rest of the lesson is practice. How about if I have an absolute value? What about this? What about this? Like lots and lots of practice. The goal is everyone aces the test. That would be amazing. And it's super doable. All right, so I'm going to give you a minute. I want you to try B. Try to solve B.
What page are you on?
16. Try to solve B. So we should be graphing. And does everyone see how much work I showed? Like I pointed at like Y and I pointed at M. But I'm showing how I plugged in points to check which side I shaded. Like, this is why I'm telling you, look at the work I showed. I am demonstrating what I'm expecting of you on the test. I'm expecting to see a point you plugged in, and I'm expecting you to have an X where it doesn't work or a check where it works. It's showing me you know, and you're not just guessing which side. Cool, cool, cool. Try B. Try out B. So I want to see it on your paper. What haven't I called on? Jacob, how do I do the first one? Walk me through. So it's the y-intercept, 0, 1, okay.
And then it's not 4 equals 1.
We know it's dotted.
And it's -1 slope.
Cool. So -1 slope, so down 1 over 1. Down 1 over 1, so I just make a bunch of dots. Perfect. And then how do I know which side to shade, Jacob? Perfect. So 5, 5 is right here. So we're testing if this whole half right here, should it be shaded or not? That's what we're about to test. All right, so we'll plug it in. Is 5 less than -5 plus 1? Is 5 less than -4? 5 less than -4? No. Shade the other half. Wonderful. Okay. Pick someone else for the second one. Natalie, how do I do the second one? Cool, so that's the y-intercept. Got it. So the slope is 2, right? So rise 2 over 1, rise 2 over 1. Should it be dotted or solid? How do you know? Right, it's an or equal to. I'm not trying to trick you, just trying to have it be forever in your brain. Okay, so it's solid. And now, which side do I shade? -1, 1? No, because that's actually on the line. -1, 1 is right here. It's on the line. Any point, as long as it's not on the line I just drew. 0, 0. Okay, so right here we're testing. So we can go ahead and we can plug that in. So is 0 less than equal to 2 times 0 plus 3? Is 0 less than equal to 3? 0 less than 3? Yep, that's true. So know that this is the half that's going to be shaded. Wonderful. So here with my colors, it's very easy to see where the solution is. Since you're shading in pencil, if you're shading like lightly, the intersection can be darker. Caitlin, do you want to hold yours up? Exactly. And like show it around. So it's very clear. All right, does that, no, I want to make sure everyone looks. Because I can see it this far. So it's very clear if I was holding the paper this far to grade it. Like if I was holding it 12 inches from my face, I can see it. If I can see it 10 feet away, I can see it from 1 foot away. All right, so the idea is very clear. She doesn't have to label solution. I see she shaded the darker portion where they're overlapping. Like that's ideal. That's what I'd like to see. Exactly. I see Jordan's now. I can see Ruby's. This is good. So this is the portion right here. That's the solution, just to be clear. How are we feeling about this so far? Yeah? All right, let's pound it into your brain even more. How about let's go down to E. Just kidding. Example 1 here. Let's do these. Ooh, got a fraction as a slope. Yikes. All right, I'm gonna give you about a minute. I want you to try example 1. If you finish, try example B.
Yeah, I together.
Yeah? I'm trying to have you guys try it first. So what did we just do? How did we do the last ones? Exactly, that's what we're going to do. So you said here, -2 was the slope. Yep. So make a point at 5. Slope of -2, so down 2 over 1. And it will be solid because it's not equal to. Alright, so we recognize it is in slope-intercept form. If you have slope-intercept form, you graph your y-intercept, you use your slope. That takes 10 seconds. You don't have to make a t-chart. It makes it much easier. Let's see. I think that looks good. Alright, so we got to figure out which side to shade. So Caitlin, which side do I shade? Do you want to pick a point for us? Any point. 6, 7, so that's right here. So I'm going to plug in 6, 7. So is 7 less than equal to -2 times 6 plus 5? So this is going to be -12. -12 plus 5. Let's see, 6. -12. Oh, -12 plus 5 is -7. So I'm testing my. Is 7 less than equal to -7? Is 7 less than -7? No, it's not. 7 is not less than a negative number. Okay, since that is not true, I can't shade the half where that is. I have to shade the other side of the equation. All right, give you about 10 seconds. Try the second half. Try to do the other inequality. Yes, Jesse?
When it's a negative fraction, it's down 1, but do you move to the right 4 to the left 4?
So the negative means down. So you go rise over run, down 1 over 4.
You always move to the right,
Yeah.
though?
Yep. When we look at slope, we're always going left to right. All right, so I see a y-intercept of -6, and my slope is -1/4. So I draw a dot at -6, and then slope of -1/4. So down 1 over 1, 2, 3, 4. Down 1 over 4. And this is going to be a dashed line because it's just a greater than or less than. So notice I put my dots going to the right. You just need 2 points and you connect them, make a line, and if you have a ruler, you can just do the dashes as you go along with the ruler. Okay. Something like that. Okay, and then Jesse, you want to pick a point for me?
Yeah, I did 0, 0.
Perfect. 0, 0 is right here. It's not on the line, so I can plug it in. Is 0 greater than negative 1/4 times 0 minus 6? Is 0 greater than negative 6? Yes. Since that is true, I will shade the half where 0, 0 is. When I say the half, I mean the line divides my whole graph into 2 parts. So whatever part, whichever half that my point is in, that is the side I will shade. What? So this is the portion right here that's overlapping, and that would be the solution. If you're done with this one, try the next one that's below. So I want you guys to do it without your calculator. Try to graph it without your calculator, using slope-intercept method. Sweet. Yeah, you can check. Do we have questions? If we don't understand the process, like, it's a great time to ask. If we can figure out what part is confusing, I can try to be more clear. Okay, so for the first one, do you want me to go back? Yeah, it's fine. Yeah. Okay. Cool. All right, so this first one, y-intercept of 8, slope of negative 4. So I go up to 8, draw a dot, down. So negative 4 slope means down 4 over 1. So down 4 over 1, down 4 over 1, down 4 over 1, down 4 over 1. And it's going to be solid because it's more equal to. Can you guys see the blue? Is that okay? Hopefully you can see it. Okay, so there's my line, solid. And then I have to decide which half do I shade. Yeah, so down 4 over 1. So this is a negative slope because it goes down as we go left to right. It's going down. Let's see. I'm gonna plug in 0, 0 because it is not on my line. Let me plug in 0, 0. So is 0 greater than or equal to 0 plus 8? Is 0 greater than 8? No, it's not. So I know I'm gonna shade the other half. So with systems inequalities, either it's the area where it overlaps, and if they don't overlap at all, it is no solution. There you go. There's your case, because we already figured it out. Let's do the other side. So same slope, different y-intercept. So I go up to 4, and the slope is negative 4. Down 4 over 1, down 4 over 1. So we notice they're parallel lines, but let's see, do they have a solution? Plug in a point. I'm going to plug in 0, 0 because it's easy to, it's 0 to figure out. Is 0 less than 4? That's true, so I know I'm going to shade that half where 0 is located. Since there is no overlapping portion, this is no solution. So notice there's a whole gap between my two inequalities. There is no area where my shading is overlapping. This is no solution. No solution. Imagine if I changed the way the inequalities were going, there would be just one like band. Imagine we shaded the other half All right, so then there would just be this band, little strip where there would be a solution. So there's your two cases. Either you have an area where they're both shaded, or there's no area where they're both shaded. And the last thing I really need to go through with you, what if we have an absolute value? Well, it's just like if we do absolute value inequalities, but now we have another one, so it's just dual shading. All right, so I want you to try the next one. I'm gonna leave this up for about another 15 seconds. Try the next one. I want to see everyone working on their paper on the next page. All right, so I think we're done with this one. So y is greater than or equal to absolute value of x. I just graphed this as if it's just absolute value of x. Now, is this going to be solid or dashed? Solid. It's solid. Okay. Because it's or equal to. Perfect. All right, so graph that. And I need to pick a point. I can't pick 0, 0 because it's literally on my line. What if I pick like, I don't know, 5, 1? 2, 1? Okay, 2, 1 it is. 2, 1. Is definitely not on my line, so I'm going to choose 2, 1, plug it in. Is 1 greater than or equal to absolute value of 2? Is 1 greater than 2? No. So I know that it has to be the other side that's going to be shaded. Yep. Because if you think about it, where this point is located, everywhere below this line is in the same area as this point.
That's right.
So I have to, potentially, we're going to finish graphing. So I have to shade the other side of the graph, which is this whole V shape. All right, let's do the other half. All right, Jordan, how did you plot the second one?
It's on the calculator.
Nope, that's not. Let's try again. How do you actually plot it? Because you won't have your calculator when we're actually plotting this part on the test. The graphing part is not on the calculator portion. So, how have we been doing it? Who hasn't talked today? Noah. Noah, how do I do this? -6 is the y-intercept, so I go down to -6. Exactly. Slope is 2, so I go up 2 over 1, up 2 over 1, up 2 over 1. Is this going to be solid or dotted, Noah? Dotted. How do you know? Exactly. It's just a greater than or less than, so it's just going to be dashes or dots, whatever. Very clear that it's not a solid line. That's all we want. And now the last part is decide which half to shade. So I need to shade either above or below. Which part do I shade, Noah? How do you know? You want to pick a point for me? 5, 5. Ooh, that's really close to the line.
5, 1.
Perfect, 5, 1. That's definitely off the line. So we're going to test 5, 1. So is 1 less than, let's see, 2 times 5 minus 6. So that's 10. 10 minus 6 is 4. Is 1 less than 4? Yeah, it is. Since that is true, I will shade that portion on the graph. Oops. Where this is, where it is. So you'll notice that there's just a very small sliver of a triangle where they're actually overlapping on this. So literally the solution for this one is this V shape right here. This portion that I'm filling in, that is the solution because that's the only place where they're overlapping. Imagine if we like zoomed out on our graph though and we could like see more of it, it would be a bigger overlap. Okay, and lastly, this is a good example to go through. So we've been doing 2, but it's possible to have 3 or 4 or 5, infinitely many inequalities graphing on the same graph. So I think I have you do one of these on your homework, finding vertices of the triangle. I'm not going to have you do it on the test. Like I have to pick and choose exactly what I want you to know how to do. So this is a nice one. So find the solution of system inequalities, find the vertices of the triangle form. So I just told you the solution is going to be a triangle, and you have to find the vertices. So automatically you know if you didn't find a triangle, it's wrong. There you go. All right, so let's go through and graph this. The easiest way to graph it is having y equals mx plus b form, slope-intercept form. So I'm going to move the y to the other side. So I'm going to add y on both sides. So I have 2x is greater than equal to y minus 1 and add 1 to both sides. So I'm showing you how I put it in y equals mx plus b form, slope-intercept form. Now that I have this, I can go through and graph. We recognize our y-intercept is 1. Put a dot at 1. Our slope is 2. So rise 2 over 1. So think, should this be solid or will it be dotted? What do we think? Solid. Why? Because it's greater than or equal to. Okay. So I want to make sure we don't miss this on our exam. It's like that color. Let's have it be a little thicker. Okay, there you go. Perfect. And then I have to choose which side to shade. I could pick any point on here. Done. What point do you want to choose to test? 2, 1, so it's right here. Okay, so we're testing 2, 1. So 2 times 2 minus 1 should be greater than or equal to negative 1. I'm just plugging straight back into the original equation. Is 4 minus 1 greater than or equal to negative 1? Is 3 greater than negative 1? Yep. So that tells me the half where this is located, I will shade. Alright, so I'm going to wait a nice 15 seconds or so, give you guys time to shade, catch up, that way it's not just bobblehead. And if you are done, try the next equation. How would I graph this? All right, Kaden, how do I get this into slope-intercept form? Yep. Minus x. All right, what's my y-intercept here, Kaden?
Y-intercept there?
Yep. Yes. And what is the slope?
-1.
-1. Is this going to be dotted or solid, Kaden? Solid. So if you guys haven't caught my drift yet, you have to know how to do this by hand. Look how much calculation we did. Very minimal. We looked at the y-intercept, we looked at the slope. We drew some lines, and then we decided how to shade. So I need to decide which half to shade. Alright, Carly, you want to pick a point, just any point as long as it's not on that blue line? 3 and -2. 3, -2, so right here. Perfect. 3, -2. So I'll plug this in. Is -2 less than equal to -3 plus 4? Because I plugged in 3 right in for x. Is -2 less than equal to 1? Is -2 less than 1? Yeah, it is. So I know I'm going to shade below my line. Cool. All right. So if you haven't already, try the third one. So I need to get this in y equals mx plus b form. So I'm going to subtract x from both sides. All right, subtract x from both sides. I have to get y by itself. Divide by 4 everywhere, because remember, I have to get y by itself. So y is greater than or equal to negative 1/4 x plus 1. What do you mean?
There's no white light.
That's fine. There's just the overlap. Remember, the solution is where all three are going to overlap. Yeah, so I draw a point. I draw a point at 1, slope of -4, so down 1 over 4, down 1 over 4. And it's going to be solid. That'll be solid. Let's see. And I decide which half to shade. I'm just going to pick 0, 0, because it's pretty simple to plug in. Is 0 greater than or equal to 1? No. So I know I'm going to shade above. So this is what Jesse was talking about, was like, wait, our whole graph is literally shaded, but there's only a small triangle portion where it's all overlapping. So the solution is literally this triangle right here. This is our solution. But wait, what are we actually supposed to be finding here? The vertices of the triangle. So what are our 3 vertices? 0, negative 0, 1, 1, 3, and then 4, 0. Those are the 3 vertices of our triangle.
I'm beating you in my calculator.